I'm going to get this session underway shortly by introducing the Chief Executive of the UK Atomic Energy Authority, Dr. Tim Bestwick. He will be followed by Paul Methven, the Chief Executive of UK Fusion Energy and the STEP Fusion Programme. Warwick Matthews, Chief Executive of Tokamak Energy, who for the techies, his name drops a heavy hint about the role right at the heart of fusion magnetics. Dr. Tom Davis, Co-founder and Chief Executive of the Advanced Materials Specialists, Oxford Sigma, and Simon Matthews, the Programme Director of the ILIOS consortium, who will tell us about plans for the redevelopment of our West Burton site. So I'm going to hand over first to Tim, who is going to set the strategic scene for the UK's fusion mission. Tim.
Do I have to turn this on or is it on? It's on. Great. I run, I think, the real risk of repeating what I said this morning, so I apologise in advance if I'm doing that. But the UK, a month ago, the UK laid out a national fusion strategy, which talked about building an industry to deliver fusion. And it is the job of UKA Group, of which Paul and I are here representing, to deliver on that strategy. There are two main parts to that group. There's the national laboratory base within UKAEA, and there is UK Fusion Energy Limited, which is the limited company set up to deliver the STEP programme. And so we both deliver that mission. It's one mission through two different mechanisms, two different flavours of strategies. UK Fusion Energy is integrating the technologies for fusion together to build a power plant, and the UK National Fusion Laboratories are developing those technologies, staying at the forefront of those and commercialising those as well. Together, we are looking to build a UK industry in fusion.
Right, check it. Oh, it's on. Fantastic. Yeah, as Tim said, two parts of the same group, and UK Fusion Energy's role in this, and the big thing we're doing, one of the big things we're doing today is publishing our strategy, is really about how we're going to achieve, firstly, the development and delivery of a prototype fusion energy plant on that coal-fired power station site at West Burton in Nottinghamshire. But actually, to do that, how we're going to go beyond. Because if we want to create a sustainable industry, and that's really the goal we have and where the value is, we can't just think about a single-shot prototype. We have to think about a sustainable industry, a sustainable supply chain beyond that. So really, this is about saying the ambition and the essential role of UK Fusion Energy is to be the UK's integrator. And through that integration, pull and drive, we actually build the sustainable supply chain we need. And as part of today, we're really, really delighted to have announced our £70 million contract with Tokamak Energy as the first system partner, primarily delivering magnet solutions for us, but also really supporting plasma development. And obviously, a couple of weeks ago, as announced by the government, the contract that we've got with Simon and his team at ILIOS, our construction partner, and that contract is obviously, and the Tokamak Energy contract similarly, are obviously just the first stages across the next 3 years, but with both organisations, their intent is to sustain that right through the long term, delivering STEP and hopefully delivering well beyond that.
Thanks very much, Paul. Warwick, if you'd like to sort of pick up the mic and talk to us with your magnetic presentation, so to speak.
A magnetic presentation. Is this one on? Yeah, just about. Yeah, I mean, today is just a really proud day for Tokamak Energy, and I think it feels like something that's come full circle, because Tokamak Energy originally was born from UKAEA, spun out from UKAEA, but that's some 17 years ago. And it's pursued a fusion device and architecture called a spherical tokamak, and it's pursued high-temperature superconducting magnets. And here we come back to where we are today, becoming partners in a big power plant program that's setting out to master those technologies. Taking a little bit more of a deeper look into what's got us here. You know, that pursuit of a spherical tokamak, and I mentioned it on the panel earlier today, made it important, actually essential, to master a new technology, high-temperature superconducting magnets. Because you can't do a compact fusion magnetic confinement machine without that. And at the time, various big players in the industry had picked up this technology, they'd tried it, and they'd failed, and they'd abandoned it. But for us, it was necessity to master that. So we originally had a team that wrote down all the 30 reasons why this technology would fail. And then we overcame those, and we became really masters in the design and manufacture of high-temperature superconducting magnet systems. Another big, and if you look on our site, we not only have a very high-performing fusion R&D device, but we have a world-leading magnet system device called Demo 4. The big change in the company that happened in 2023 was we decided that we wanted to become a commercial entity. We wanted to commercialize this great technology that we have, and we wanted to partner. And we really set out to partner in public-private partnerships. We identified STEP, and the team's been working together with UKFE for a long time. And today, that comes to announcing a signed contract, which we're super proud of. That contract will see us work hand in hand with the integrated teams within the STEP program, developing the magnet system, doing the testing. The contract sets out access to our world-leading R&D devices, both the ST40 fusion device and our Demo 4 magnet system. And we really want to be joined together with the program and deliver value to the program. This is now us becoming a partner, and our job is to deliver value to the STEP program to make it real and hit its timescales. The other thing we're doing is delivering value to the UK, and I think it's a great story that in the pursuit of fusion, we can master these technologies, achieve a step like today where we have this contract, but we're also taking this technology into a broad range of industrial applications. Last year, Tokamak Energy acquired a company called Ridgeway Machines. They're based in Leicester, again in the heart of the UK, moving slightly north from Oxfordshire towards the STEP site. Ridgeway's a great company because they make the best machines in the world to wind superconducting magnets and superconducting cables. We bring all of this to the program, but by delivering under this contract, we're creating the supply chains, the economic impact that we want to see from this whole program. And we're immensely proud of our team working with UKFE to achieve this. The hard work starts here, and we look forward to that day one of being under this contract and delivering.
Thanks very much, Warwick. Appreciate it. So obviously, cutting-edge technology innovation is going to be at the heart of UK fusion progress. I'm going to invite Tom now from Oxford Sigma to talk to us about the materials end of that journey.
Thank you. I'm Tom, co-founder and CEO of Oxford Sigma. We're a small company of about 25 people based in Oxford and at Cullum site. I founded the company 7 years ago on the premise of solving some of the advanced material challenges in fusion energy as a whole. But over those 7 years, I kind of want to tell a story of, just from an SME's perspective. I work with a lot of other SMEs around that area in the UK. So this is kind of just a story about how the STEP program, as it evolved over those time, and how it's given us stability, given us vision, and actually what the requirements are, and how to strengthen our the resilience in our organisation, but also working with other suppliers who are very like-minded, small, niche, providing very key skill sets to deliver the STEP mission. I've personally been involved in STEP since its near inception, about 2020. So I've seen it gone through some various design iterations, whether that's through contracting or whether that's through reviewing and stuff. So personally, it's quite of a proud moment, like Warwick and that, to come this far as a humble supplier back in. But I'm going to stay in Oxfordshire in this case. I'm sorry, as where we live. But wider to that, we work very closely with UK Atomic Energy Authority. We've been supported quite well over the years on innovative material designs, innovative grants to able to generate the IP, generate the value, give us that sort of position within the market where we can actually now start delivering as STEP grows to this delivery organisation and be the value that we want to become, and actually be able to deliver to the program. And I can say that on behalf of a lot of other SMEs that actually work with quite closely in and around the county, but also wider to that, and we do work a lot in the north as well. Worked with Tokamak Energy very closely over the years as well. So it's a very, there's this ecosystem that's been generating, and you'll feel that when you come to the Cullum site and go to West Burton site, and you'll see it grow. And that's what I kind of come from. We're doing our best, with delivering what is, in this case, advanced materials. And talking about, we could talk about tritium breeding that we provide as manufacturing products, some radiation shielding, key technologies. And a lot of that we're kind of keep in the UK and keep that sort of niche skill set which is essential for delivering such a national program and beyond. We want to export, we want to generate, grow the company. So all of this is about value generation. So to me, kind of at one end of that, that's kind of maybe what I represent here. But there's many other organisations around this ecosystem that are very much like Oxford Sigma, have their niche skill set, which are are required and needed by a large a fusion program in general. That's kind of what I wanted just to bring to the table here. So thank you.
Thanks very much, Tom. We've heard about the technology development taking place at Culham and Oxford. If you take a train up from King's Cross on the East Coast Main Line and go to a place called Retford, hop in a car for 20 minutes and you'll see some enormous cooling towers looming out of the mist. That is where West Burton Power Station is. It's where the first working fusion pilot product plant is going to be built. Simon Matthews is the man leading the redevelopment of that site. Simon.
Thank you, Richard. Yes, I think I'll talk today about building fusion facilities at work and from first design to long-term value and our role as a construction partner in doing that. And take a little step back, fusion is often described as a scientific breakthrough, but that's often enabled by the facilities that we need to build, design, build, operate and maintain safely for a number of years. And it's not whether we can build the facility, it's whether we can build it in a way that is sustainable and drives that long-term value. And it continues to work from day one. And we have just started, as Paul mentioned, we were appointed earlier in the month, late last month around, after a long procurement exercise, but our journey is just beginning, but it gives us an opportunity to shape delivery right from the outset. So we can look at safety, buildability and long-term performance in the design of the operating fusion facility. And I think early involvement of partners like ourselves is really important. When the technical requirements are still evolving on STEP, early decisions on how the facility is designed and built is really important, and they shape safety, cost and schedule over a number of years. And bringing our expertise in early is essential to make sure that those programs are delivered predictably and reliably. And that is done through early collaboration, by turning design intent into something that can be built and commissioned efficiently. Put simply, early involvement is one of the key ways to make sure that we protect safety, cost and schedule at all times. And when we think about the design, we've also got to think about the operation. So STEP won't just be built, it will be operated and maintained for a number of years. So whilst we focus on the construction, it's very much about thinking that the design has to take into account the operation of the plant in the long term. And that means applying safety by design. So making sure that the building layouts and systems are designed to minimise risk, that interfaces are there and clearly understood to minimise likelihood of error, and maintainability is included within the design of the plant to make sure that it can be maintained safely and functionally as we move forward. So success in fusion isn't just about first plasma, it's about reliable performance year after year. When we think about efficiency on large projects, obviously projects often are set with delays due to complexity, and that's often down to complications that arise. It's not specifically around one discipline, it's very much about the interface between the different disciplines, whether that's design, construction, operations or maintenance. And the STEP programme, the way it's been set up and the way the operating model has been designed is about having an integrated team. This isn't a conventional model, this is about making sure that we work as a team of teams, as one system, rather than relying on a series of handovers. And efficiency isn't about doing things faster, it's about doing them once and doing them well. And we need to think about digital, and I think a lot of what we're having to move towards now is making sure that digital thinking is embedded in the programme from day one, so that requirements, interfaces and evidence stay connected with the plant all the way through from design, build, commissioning and operations. So having that digital thread and that single source of truth is essential. So digital integration is how we make doing it once real. And finally, it's about skills. I think the fusion is a skills challenge as well as a technical challenge. And facilities like STEP need advanced construction capability. It needs the right safety culture. And those skills don't appear overnight. So what STEP programme gives us opportunity to do is engage the supply chain early. It's to invest in training and capability and build that magnetic centre for the STEP at West Burton site. That will generate long-term, high-value careers not only in the East Midlands but beyond. And for fusion to have to scale, as you've seen today, the skills base has to scale with it. And finally, I think for us, STEP is about building a world-class engineering project safely and efficiently. But it also means that we will generate a new industry. And we're very keen to work with STEP and industry partners to create a new industry. So that's new skills, new careers, and long-term economic growth that's rooted in the UK. So for me personally, and for myself and the wider ILIOS team, we're very excited to be on board this with Paul and the team to be part of the STEP mission. And we look forward to taking a key role in the STEP endeavour. So thank you.
Thanks so much, Simon, for that concluding presentation. So a very big thank you to some of the most senior people in the UK's Future Energy Programme for coming together in one place to bring us up to speed. What we can take away from this is that the UK does have a clear strategy, that world-class expertise, collaboration and coordination are hugely significant components in the progress that we need to make. That progress is going to raise questions, and this is your chance to put your hand up, say who you are, and ask the people at the sharp end those questions. So the floor is yours.
Margaret Harris, Physics World Magazine. My question is, how does this integrate, or does it integrate at all with the UK's contribution to ITER, which is also, I believe, targeting some progress by the mid-2030s and into 2040?
So the UK was a member of ITER through our membership of the European Union. But now that we are no longer in the European Union, we do not have an official relationship with ITER. That's just where we're at. We have some, we stay in touch to the extent that we can, but I'm afraid with one of the consequences of Brexit, we're not in that programme.
Thank you so much. Thank you enormously. The Minister just talked about international collaboration, and we're talking about a mega project. What's the prospect of really creating international collaboration and true collaboration into such a project?
It's great when you get questions from your own non-execs. Thanks, Luke, for that. It is a great question, though. So I think, look, international collaboration is essential for the delivery of fusion. I think sometimes there can be a view that collaboration is either 0 or 100%. And I don't take that view. And I think we're at a point in the maturation of fusion now where companies and countries, and sometimes both coming together, collaborate on what makes sense for that collaboration, not as a sort of thesis in itself that collaboration is the answer to everything. So, to give you an example, the US and the UK have a bilateral agreement. It actually covers overall nuclear energy, of which fusion is a component. And we seek to do work with the United States on the laboratory side, in the national lab sense. And there are relationships with all the key facilities in the US. But also with some US companies, and we're working with some US companies, for example, in the AI space at the moment, exploring the potential for AI to help solve some of the challenges in fusion technically and also in the delivery space. And it makes sense to do that, and we'll keep doing that. There are some other international collaborations we're looking at where there's mutual interest. So what I see probably much less likely is a repeat of ITER on a commercial scale, where actually multiple nations come together to do one single, either huge experiment or power plant. That is extremely difficult to coordinate. Gusting inefficient. I think it's actually remarkable what ITER's managed to achieve in delivery terms, and hopefully will in science terms. So I think the components of this are amenable to collaboration to a level where it's mutually of interest, but full power plant delivery feels more like a national or a company-led endeavour.
Could I possibly add to that one as well? I think it's also where the commercial companies coming in now play a role as partners in the programme. The Minister did reference the LEAPS programme, which is the snappy title for lithium evaporation and advanced plasma-facing components, which is quite a mouthful. That is a programme where it's on our device at Tokamak Energy, ST40, but it involves both the UK Department of Energy Security Net Zero and the US Department of Energy, who both have a keen interest in that programme. We're a company that, although we're small, we're around 330 people, we do have a well-established subsidiary in the US, and we have a subsidiary in Japan. And part of that is because we've got a lot of commercial activity in Japan. We have a very important shareholder, Furukawa Electric, in Japan. And as we look at building out the necessary supply chains for STEP, we want to be doing that in the UK, but we're also got a keen eye on what international partners can bring in, and ideally land that capability in the UK to give us that sovereign capability in the country.
Thanks very much, Warren.
Yeah, I can add a sort of a story here to this theme. So as Oxford Sigma, we also have a US company, again, driven by commercial activity, but what's driven that to make those decisions is actually based upon some of the development work we've done in the UK on some of the manufacturing. In this case, it's lithium ceramics for tritium breeding, a component for a fusion reactor, but it's actually all manufactured in-house in the UK by us. But the majority of the funding that developed that IP was actually UK grants and through UK Tokamak Energy Authority, through the Fusion Industry Programme. But that's put us in a position now we have exported, and we continue to export to United States and to other European companies as well, and both national labs and also commercial companies in those countries. There's a very small, modest approach, but it will grow in time as and when fusion grows. But there's like a little small story of how a small, small, 25 bit smaller than Tokamak Energy, but we're able to actually generate some growth and some of that stimulated by exporting, in this case, manufactured material, all in-house in the UK, keeping that sovereign capability available, and it will grow within Fusion as Fusion grows.
Okay, have we got any more non-execs or even journalists?
I'm Jeff, from a reporter from Tech Journal. So I want to know how the UK is attracting private investment in fusion energy. So it seems now is most of the investments are made by the government. Yeah. What efforts have been done?
I would say at the highest level, we're trying to create a place where the opportunities arise for investment, exciting opportunities. So we are actively trying to do what we can to generate investment opportunities. Be that by having national programs that are putting money into the supply chain and driving technical capability in industry, spinning out new companies which themselves will seek investment, creating joint ventures with existing companies which hopefully will grow and become investment opportunities. So I think the prime tactic is create the opportunity. I believe that international investment capital will flow to where the opportunities are. So that's the approach we've taken.
Yeah, I mean, I think I can summarise by saying what we're trying to do is crowd in, not crowd out. So, if you look at exactly what we're doing, and maybe Warwick will comment on investment rounds because he's in the receipt of them, is that the government investment is not in place of private investment, it is in order to generate private investment. In other words, if the government backs what we're doing confidently and takes some of the risk out of it, that creates a landscape where the private sector and private investors can come in with much more confidence. And I think we're seeing that momentum start to spin positively now.
Yeah, and it's a very live question for us. I think you're seeing this sort of trickle-down effect. I would describe it as this strategy for a company like us is a catalytic effect on our investment, because investors, you're not selling with PowerPoint. You're selling with real facilities, with government as customer in these cases. But there is a demand that's created here for bigger and bigger magnet systems and the work that we're doing, which can allow us to spool up our teams, our capabilities, our facility size on that demand. And you have that certainty. And off that, you can build into further opportunities, international expansion. Definitely our intent is to be a significant exporter from the UK as well of this capability. So it's the catalyst that allows us to address investors with a totally different narrative.